what is the first thing that comes to your mind when I say auditory system? Who can tell me that? Come on, let's have a quick discussion.
Hearing sound. Hearing.
Hearing of a sound. Okay. So there are a lot of, you can say, attributes to a sound. You know, we'll go for the pitch, we go for the frequency, and you ask a musician, there is a lot of whole things. We say you have got a musical ear, you know, you are able to hear it well, you are able to understand it more. But here today I'm going to talk about is the physiology of the ear. Now, before I go into the physiology of the auditory system, I want you to understand what is the anatomy of the system. So all of us know we humans have 2 ears, isn't it? Hanging very nicely on the 2 sides of our skull is the 2 ears. And the ladies and the nowadays gents, they hang many other stuff onto this outer ear, what we call as the pinna. Look at the structure. If you touch your ear, you will see that it is not a bony structure. Rather, it is a cartilaginous structure. And you can fold it. We humans don't have that ability of waving our ears. But if you look at animals like cows, buffaloes, or, you know, such where they can easily, you know, even the elephants, you can see how nicely they'll be flipping their ears. So they have this capacity of flipping this pinna. This ear, which we are nicely able to move, we are hanging on to stuff, whatever we want, is what is called as the pinna. Now, if you look, you know, to yourself also, you must have felt that there are a lot of ridges here. You know, there are a lot of ridges. Has anybody thought what is the function of these ridges? Yes. Have you ever thought? You just put your fingers. It's bad manner to do so. But for now, I can ask you, if you put your fingers near to your ear, you do find many ridges. And then you find a hole which is trying to go inside. What do you think is the function of these ridges? Yes, somebody can answer me.
They help funnel the sound waves, like they cause repeated reverberations and direct the sound waves towards the canal.
Okay, so they probably have been aligned in such a way that they can funnel your sound. Sound is anyway, you know, it's just another form of energy which is being transmitted through air. Does sound travel in vacuum? If we do not have any medium, does it do? Okay, so that is one way. Then if we feel it inside, we have a canal. So how does this canal go? As if you have put your hand into your pockets. Pant pockets, not the straight pockets. I'm talking about the pockets which your father or grandfather used to get the pants stitched, and the tailors used to have a slit pocket. You remember that? You put your hand so into those pockets. How does your hand move? It first goes anteriorly, then to the medial side, isn't it? So that is how the ear canal goes. That's how the orientation of the ear canal is. Then the first thing that the sound comes across. So let me take you to the anatomy of ear as if the sound is traveling through this ear. Okay, so let me just take the pathway as how the sound would be traveling. Sound is somewhere here, maybe a large sound or a suitable sound is there. The sound waves are going to go through the edges. They are going to, you know, your pinna is going to direct them, kind of funnel them into the ear canal. When they may go into the ear canal, the first thing that they encounter too, which they kind of going to go and vibrate, is what you call as the tympanic membrane or the eardrum. This is called as the tympanic membrane or the eardrum. Back to the tympanic membrane, you know, kind of, and this point where this malleus is attached to the tympanic membrane is what is called as umbo. Okay, the malleus now is connected to incus. So there is something malleus which is handle-like stuff which is now connected to incus, and this incus is connected to a small foot-like process. You know, if you have done the horse riding, when you sit on a horse, you are supposed to, you know, kind of put your foot into a stapes. A bony structure, something what represents like a stapes, hence it has been named as stapes. So these are the 3 bones. These are the smallest bones of your body. Okay, they are not as large as your other axial bones or other bones of your body. They're very small. They are the smallest bones of your body. And what are the 3 bones? Malleus, incus, and stapes. Okay, so sound was traveling through the ear canal, had traveled through the eardrum, has vibrated the eardrum, and that pressure is now being transmitted by the malleus, the incus, and the stapes. And this stapes, because of the pressure which is coming here, the air pressure, it's going to, what is it going to do? It's going to vibrate another window, which is called as the oval window. Now, where is this oval window window is attached to a snail-like structure, which is bony-like structure. You know, it's very similar how a snail is. Cochlea is having an attachment to structures of semicircular canals and articles and all, which is going to form your vestibular apparatus. Now, the question arises, what is so important about vestibular apparatus? I think many of you would have traveled the Gouty road. Can I take it a common thing that most of you have traveled the Gouty road? How many of you feel this motion sickness? Have you ever imagined of this motion sickness? Have anybody experienced the motion sickness?
Yes, ma'am.
When you go to hilly structures, you know, hilly areas, Gouty roads, the roads, why do you have so?
Because the fluid, like the fluid is not stable, it vibrates.
You know, where your cochlea, which acts for the hearing aid, means it acts for as if for your assistance to make you hear about the things. For audition, your vestibular apparatus is important for maintenance of equilibrium, your posture and equilibrium, especially to do with your head movement, whether it's a head rotatory movement or sidewise movements. So this stapes is actually closing a window. I can say the word closing a window, because now hereafter, you know, it goes into a structure which is membranous here inside this bony structure, as if they have made a 2.5 coils. Okay, this coil is called as the cochlea. Then inside that is a fluid. We are going to go in detail about cochlea, the compartments of cochlea, the fluid inside the cochlea. Then here is what you call as the oval window. Then we will see that there is a connection like this, which goes here, here, and then there is something called as the round window here. Now, why did I say so? When the sound comes, it vibrates the tympanic membrane. It vibrates the bones, the 3 bones, that is malleus, incus, and stapes. This stapes is going to cause the vibration in the oval window. The vibration in the oval window will be transmitted through the fluid which is present in the cochlea, and this is again going to cause the reverberation in the round window. Okay, so when there is a movement, when the sound is traveling through this, there is a membrane inside which is going to sense the amplitude of your sound, and that is through where, you know, there will be organ of corti. We are going to talk about the organ of corti, which is again very important part for hearing, and the nerve cells. Here the cells which are important for auditory system is the hair cells, and then the auditory nerve, which is going to carry the information to the auditory cortex. How for the visual system, we had the receptors, rods and cones. Here in case of auditory system, we have the receptors which we call as the hair cells. The hair cells again are divided based on their location as inner hair cells and outer hair cells. Okay, this is all that I wanted to give an overview about how sound is traveling through the ear. So let me just show you one video.
Sure.
So what is ear? Ear is a transducer. How it is a transducer? It is converting the sound energy from outside as it's coming as a sound, where it is causing the vibration of the handle, the anvil, and the stirrup, which is called as the stapes, into a mechanical energy. And this mechanical energy is again transmitted and is being sensed as an action potential, which is again an electrical energy. So you can see that the sound which was traveling before through the air medium, it hits the tympanic membrane, gets converted into mechanical energy, which gets further converted into an electrical energy and reaches to the auditory centers. So what is hearing? Hearing is perception of sound, ability to hear a sound. Now, perception of frequency is called as pitch. This is what we learn new. And the perception of intensity is what is called as loudness, just to make a difference between pitch and loudness. So let's go into the functions of external ear, middle ear, inner ear. So if you want to know the functions, so we are kind of dividing the ear in three parts. The external ear, which is the pinna. So what are the functions of external ear? As we have talked, so what is the function of external ear? It is going to collect the sound, collection of sound, and increasing the pressure on the tympanic membrane in a frequency sensitive way. And the other is source localization. So suppose we are kind of trying to locate where exactly the sound is coming from, we will put our ears towards that source of sound, isn't it? So that we are able to hear it more clearly. So the clearer we kind of hear the sound, we become more sure, okay, that particular sound source is very close to us. Very, very important for examination point of view, and otherwise also it is the function of the middle ear. There are three functions which we are talking about. One is called as impedance matching. The other is called as attenuation. And the third one is called as the phase differential. So we are going to talk in detail about the impedance matching. Now, what is impedance? Can anybody tell me? What do you understand by impedance? In general term, what do you mean by impedance? Yes, can anybody tell me what is the meaning of impedance?
Impedance is, in electronics, impedance is resistance caused by several components.
So whatever you have told in electronics is very kind of similar here also. So it is hindrance or the resistance, okay? The resistance which is offered to the flow of current, isn't it? That is what I remember from electrical term. We are kind of going to apply the pressure on the tympanic membrane because of the sound coming and hitting my tympanic membrane. And this pressure which is applied here as P1, the pressure which is applied in the oval window, that is P2, is more than the pressure which is kind of being applied by the sound wave at the tympanic membrane. So what your middle ear does, it matches the impedance, or it does the impedance matching for the sound wave. So let us start with how it is being done by the ear. How does the ear do? So we have the three bones. What are the three bones? Malleus, incus, and stapes. Malleus is also called as the hammer, incus, the anvil, and the stapes is what is called as the stirrup. Okay. Now, what is that we are going to do here by this is this energy, which the acoustic energy, the energy, sound energy, which is entering the cochlea, is being aided, or you can say it's being getting kind of increased in their pressure or force by the anatomical impedance, which is being matched by these middle ear structures, whom we call as these three bone structures and two muscles. So the purpose of the whole of these bones is to match the impedance of it. So let us see how it is done. The tympanic membrane, let us see what is the force which is applied at the tympanic membrane. So we look at the area. The area is suppose A1. And what is it? The pressure which is applied here is P1. So force is equal to P1 A1. So that is what is happening at the eardrum. Then what is this F1 doing? F1 is kind of giving to the malleus, is getting what you call as, it is going on to getting transmitted to the malleus or the hammer. Then it makes the movement of the anvil, and then the stapes. So there is a fulcrum movement at the stapes. Now stapes is going to vibrate, kind of up, down near to the oval window. So it is kind of getting moved here. Can you all see this?
Yes, ma'am.
Yes, ma'am.
Yeah. So this is what I wanted to tell you. This is called as the malleus, the head of the malleus. Okay, this is called as the handle of malleus. As you can see, it is labeled also. This handle is attached to the tympanic membrane. Okay, so when the membrane vibrates, it causes the movement of the malleus. And you can see the malleus and incus is also joined together by incudo, this one, see, incudo-malleolar joint. So there is a joining of malleolus with the incus, and this incus is joined to the stapes by another joint. Okay, so this base of the stapes is actually, as if you have to imagine this base is stuck onto a membranous structure of another hole, which is kind of oval in structure, and this forms the oval window. I hope you can imagine that there is a membrane attached to here. So when malleus moves, incus moves, and the stapes also moves. If you look at the area of the tympanic membrane and the oval window, because after the oval window, what we have is the inner ear. And inner ear has got the liquid and has got the basilar membrane. And the basilar membrane is the one which is going to respond to different frequency of sounds. Okay, so the higher frequency sounds will be heard at the apex one, the lower frequency will be at the base one. This we are going to study later. Now, how does this impedance matching is done is because of amplification in the pressure which is applied at the oval window. How this amplification of pressure is occurring is because that there are two things which is happening. One is, see, look at this, because of the lever action of the bones, which are very faithfully transmitting the energy, sound energy to the oval window, and the other is the difference in the area. So since oval window area is lesser, A2 is less than A1, when we look here, A2 is less than A1, the force which is, and due to this lever action of the bones, F2 is greater than F1. Ultimately, what we get, if I apply the formula, we get it that P2 is greater than P1. Then impedance matching we have just talked about is because of the three things. One is the oscillar movement, lever action, and the change in the surface area. So what we have seen is the force of movement is increased by 1.3 times. F2 is getting increased because of the lever action of the ossicles. Then surface area of tympanic membrane is 60 millimeter per square, whereas that of the stapes is 3.2 millimeter square. So there is reduction in the area at the stapes. F2 is increased, A2 is decreased. So what is happening to P2? P2 is increased than P1. So we find that there is an increase in the pressure by 17-fold when we look at the tympanic area. Now, how is this lever action of ossicles happening? We have seen that if you look at the three bones, again, I'm naming the three bones. What is this? This is the malleus, head of the malleus, handle of the malleus. It is joined with the incus to the stapes. The other name for this is named as if it's a hammer. This is called as the anvil, and this is called as the stirrup. Now, what is happening here is, if you look at the handle of malleus is 1.3 times longer than the long process of incus. So, that also is going to cause a lever action to the ossicles. So we have seen what is the force applied at the tympanic membrane area near to the eardrum, and the force which is applied at the oval window. So F2 is greater than F1. If you look at the D1, D1 is greater than D2. So that is going to have another lever action for us. Ultimately, if you look at the area also, area of A2 is smaller than A1. Then what is all of these leading to is that there is increase in the pressure of the sound waves which is reaching to the oval window. Now, what is this called as attenuation reflex? So we have to know the the middle ear is formed by the three bones and the two muscles. What are these two muscles? They are the smallest muscles again, the stapedius muscle and the tensor tympani muscles. What do I mean by this attenuation reflex? So recently we had Diwali, celebration of Diwali, isn't it? So how many, although it is banned in many parts of India, but still people do firecrackers. So if there is a cracker going to burst in front of you, you know that, somebody is just lighting it. What is your reaction to yourself? Can anybody share me? What do? You just put your hands.
Reflex to put the hands on the ear.
Yes, and the other way is you just kind of, stiffen yourself,
Yes.
and what you cannot feel is that your muscles, they just also go for contraction, and they keep the things very stout, so that if you suddenly, you must have realized that suddenly, many times there is a bursting sound of the tires. People whose house is near to the main roads, you must have heard suddenly there will be a burst of the tires. If you are not aware of anything, you kind of are not aware that there will be a sudden sound, and if you hear such a loud sound, it may be very hampering to you. If somebody comes suddenly near to your ear and just crackles an atom bomb of Diwali, the protective reaction wouldn't be there, and that would have probably, for some moment of time, you feel as if you're not able to hear anything, or you kind of hear a simple tinnitus sound, a one pitch sound, very one tone sound you'll be hearing for some time. If that reflex was not present when a loud sound is transmitted through this ossicular system, and if there is no attenuation reflex, means this contraction of stapedius muscle and the tensor tympani, that would actually hamper your eardrum. Your eardrum wouldn't be taut enough, and so to a very large sound, it may just respond by, that large sound may just break off the tympanic membrane. So that's attenuation reflex is actually a protective reflex. So what does it say? When loud sounds are transmitted through the ossicular system and from there into the central nervous system, a reflex occurs after a latent period of 40 to 80 milliseconds to cause a contraction of the stapedius muscle and to lesser extent the tensor tympani. What does this tensor tympani do? The tensor tympani muscle, it pulls the handle of malleus inward while the stapedius muscle pulls the stapes outward. So your handle is pulled inward and your stapes is pulled outward. You kind of have become two opposite forces are going to act. Now these two forces which are opposite to each other, they'll cause entire ossicular system to develop a rigidity. And this rigidity which is being developed in the ossicular system is kind of a protective reflex, which is going to reduce the conduction of the sound. So your brain is not going to perceive this huge loud sounds, because as we all know, human ear can kind of take up the sounds between 20 to 2000 hertz or 20,000 hertz. I think 2 to 20,000, right? Beyond that, we call it as ultra or infra sounds, how we have for the infrared rays and ultra rays for the eye. So this attenuation reflex is a protective reflex which kind of regulates the amount of sound to be conducted through the middle ear. So middle ear has got a function of impedance matching. It has got a function of attenuation reflex. Attenuation reflex is a protective reflex. The function of this mechanism is believed to be twofold. One is the protection, as I have told you. Protect the cochlea from damaging vibrations caused by excessively loud sound. And the other is to mask low frequency sounds in loud environments. So if you're kind of responding to every sound, you will be actually transmitting a lot of noise to your inner ear. And the inner ear will not be able to differentiate what sound, what meaning of sound, where the sound is coming from. So it masks the lower frequency sounds in loud environments and thus removes a lot of background noise. And so you're able to hear your own speech or others' speech. Okay. Now, there is something called as phase differential effect. So what is it? The sound waves which are striking your tympanic membrane, they do not reach the oval window or the round window simultaneously, means at the same time, there is going to be a difference in the preferential pathway. So what is it? Your ossicular system is attached to the oval window, but round window movement is due to the movement of the liquid. We are going to see it. When we study still more, you will be able to understand how oval window is attached and how round window is attached. This separation of sounds, acoustic separations of sound, is probably achieved by intact tympanic membrane and the cushion of air around the round window. So this reflects, this phase differential effect which is seen between the oval window and the round window is contributing to about 4 decibel when the tympanic membrane is intact. So if we come to functions of middle ear, there were 3 functions. One is impedance matching. We have understood how is this impedance matching brought about because of the change in the area, surface area of the tympanic membrane and the oval window. Next is the lever functions of your ossicular system. Okay, so that is one thing. And then what is it? We have talked about the surface area, the force of movement, and the pressure change that we get to see. Then the other is attenuation reflex, a protective reflex, and the phase differential reflex.